If you want to work on next-gen AI systems at top companies like Google, Meta, OpenAI, this roadmap can make you pro from noob, from GenAI, LLMs, RAG to Agentic AI. It covers every topic, and this is the master of all the roadmaps for you. It can also help you with what to learn and in which order, which topics to learn, and how to stay updated with the latest research as well. And these are the things that you will learn from this video, like the prerequisites of Gen AI, Generative AI, and the LLM roadmap, and RAG roadmap, Agentic AI roadmap, along with all the integration of these learnings into the system design and the FANG level preparation for the AI engineer, and how to stay updated with the latest research and the continuous learning about the Gen AI as well. So it's the only roadmap you need from now. So make sure you save this video. So hi guys, welcome to FreeBirds you, and let's get started with the roadmap. Our first point is prerequisites before jumping to the Gen AI. Because without fundamental or the foundational knowledge, learning Gen AI is like dancing without music. So you have to go step by step. And here is the list of the foundational topics that you must learn before jumping into the generative AI, LLMs, or even agentic AI as well. First topic is mathematics. Learn about the linear algebra, vectors, matrices as well, along with the basic knowledge of calculus, derivative, gradients, along with the information theory, and become experts in the statistics and the probability as well. Learn about the chain rule or the expectations based theorem and the statistical test that you can do on the data to check its significance as well, and have the basic knowledge about the optimization theory that includes the gradient descent variants, the Adam optimizer, along with the regularization as well. Before anything in ML or AI, math is very, very important. Okay, and then shift to the programming or the software engineering part, in which you first learn about the Python programming, including its data structures, functional programming, the OOPS concept as well, and some important libraries that you can use in the GenAI or the ML or data science as well, that are NumPy, Pandas, Scikit-learn, PyTorch, or the TensorFlow as well. And also learn about the basics of the software engineering by using the version control or the unit testing or the modular code design, along with the basics of CI/CD pipelines. And then learn about the data pipelines, like by using the ETL or handling the large data sets by using the Spark, and the data preprocessing, the batching, and the streaming data handling as well. And then shift to the machine learning fundamentals. Learn about the supervised learning, that means about the regression, classification, loss functions, overfitting, underfitting, cross validation, along with the unsupervised learning like clustering, dimensional reduction, or the autoencoders. And then make sure you learn about the evaluation matrices and how you can evaluate your any type of model. Okay, by using accuracy, precision, recall, F1 score, AUC, ROC curve, MA, MSC. Okay, and then you have a very good knowledge about the feature engineering that includes the scaling, normalization, categorical encoding, along with the handling messy data or the outliers, and also creating new feature out of your data as well. You should have a basic knowledge about the deep learning as well. That means about the neural networks like perceptrons, multi-layer perceptrons, the activation functions like ReLU, sigmoid, or the back propagation as well, along with the architectures of the convolutional neural networks, recurrent neural networks, LSTMs, GRUs as well, and the regularizations such as the dropout, batch normalization, and transfer learning, and the fine tuning. These are the like topics that you don't need to go in very depth, but at least you know how they work and how to use them when in need, because in production the speed of your response is always the priority rather than the size of your model as well. And to get your job in FANG or the more product-based companies, and to increase your problem-solving skill, learn about the data structures and the algorithms. So learn about big O notation, time space complexity, graph, trees, and all type of data structures as well. Their coding patterns like recursion, dynamic programming, sliding window, two pointers as well. And along with the scalability, learn about the streaming algorithms, the concurrency, multi-threading, multi-processing as well. Then at least you have the awareness about the DevOps, MLOps as well. That means you have a conceptual knowledge about the model deployment, monitoring, and the versioning, along with the basics of the containerization by using Dockers, and the orchestrations of the models using the Kubernetes as well, the load balancing basics along with the logging and the monitoring as well. Okay, and with these foundations in place, let's move to the heart of today's roadmap, that is called as generative AI or large language model. That is our first stage here. So a tip before going ahead: don't be overwhelmed by all the topics. Just learn one by one and step by step. And if any question, please ask in the comment section. Okay. Okay. So for generative AI, learn what generative AI is, why LLMs are so popular nowadays, and then dive into their architectures, their training, their inferences, their engineering, and their limitations as well. This is a core stage for the FANG level depth that you need to become a master AI engineer. Means the first you have to learn about the generative models, their major families like the GANs, the generative adversarial networks, or the variational autoencoders as well, along with the flow models and diffusion models as well, and their use cases like image generation, language generation, or the synthetic data generation, or the language translation as well, and why the focus shift towards the large language model in 2025 or in the next decade as well. And what this is done, then move to the NLP part like tokenization, embedding models, and language modeling part as well, in which you will learn about the tokenization methods such as the byte pair encoding, sentence piece, or word piece, along with the embeddings such as the positional embeddings, the token embeddings, along with the embedding models. Okay, and how embedding models are built, and then learn about the language modeling paradigms as well, such as autoregressive models, for example, ChatGPT, and the mask language models such as the BERT, and along with the prefix language model as well, along with the representation states such as the hidden states or the attention weights as well. And then move to the actual large language models, in which you learn about what is the large language model, its architecture, its use cases, and its historical progression from the one-hot encoding to the TF-IDF as well, to the bag of words, to the word embedding, word to vec, RNN, and then to the transformers as well. Okay, so why we need this long progression there? You have to know about each of the pros and cons of each method and tool that can help us in the understanding of the textual data in the numerical form. Okay, and then go deep down into the transformer architectures. Learn about the self-attention mechanism, queries, key and values, scale dot product, multi-head attention, positional encoding, flash attention as well, along with the encoder and decoder architectures, along with the there are multiple variants of the transformers like GPT style or the BERT style or the P5 style as well. And then learn about the complexity of these large language models, like their parameter count that increase the size of the large language models, or the memory and the compute cost as well. Okay, you need to know about their trade-offs as well, that when we need which kind of thing for our particular use case. And when you feel confident in all this, then move to the training of large language models, in which you learn about the pre-training, like you have objective like language modeling, mass language modeling, or the next word prediction as well. Okay, and then we have the fine-tuning of the language models, means you have a specific task or specific domain in your mind for which you have to fine-tune your language model as well, with the help of parameter efficient fine-tuning, like using the LoRa or the QLORA architectures as well. And then learn about the reinforcement learning with the human feedback. That means you can add the reward modeling or the policy optimization with multiple experiments to make your language model free from the hallucination, and also learn about a particular style to answer the questions as well. And also learn about the basics of GPUs, TPUs, distributed computings, that how it works, and have the basic knowledge about the cost, energy, and the trade-offs between the multi head attention or the single head attention, along with the large parameter based model or the short parameter based model, a high throughput, or between the inference speed as well. Okay, and after that focus on the actual inference and the generation for the production scale large language model. So you can have to learn about the inference here, because inference matter most in the production, because you need to respond at a very high speed. Okay, so learn about the decoding strategies such as the greedy, beam search, sampling, along with the control of generation by using the prompt engineering, instruction tuning as well, or the system and the customer prompts. Okay, now also learn about the managing of the context windows using sliding windows, the context in the memory stored, and along with the chunking of the context as well, and along with the trade-off between the model size and the quantizations as well. and then shift towards the evaluation of the large language model. That's the most important topic. Learn about LLM evaluations, matrices like perplexity, blue score, rogue score, meteor, or the human evaluations as well. Along with the learn about the customer centric matrices like coherence is there, factuality, safety, alignment. Along with the benchmark suits are there like Hugging Face benchmarks like glue, super glue, or the help as well. Okay, and don't forget to know about the limitations and the challenges of the large language models, because they hallucinate, they have a factual inaccuracy as well, they have a outdated knowledge, they have a bias and fairness issues if the data is not that great. Okay, they have issues with the prompt injections as well, and they have environmental and the compute cost issues as well that can make a memory footprint or the carbon footprint as well. With all these topics in mind, now you can easily focus on the advanced topics of engineering at scale, like a FANG level. So explore the advanced topics like model parallelism, data parallelism, and pipeline parallelism as well, along with the sharding of the database, mixed precision of the weights in large language models, and serving infrastructures on the REST API or the gRPC endpoints by using the batching, caching, or the auto scaling as well, and monitoring and logging of the large language model drifts, latency, along with the error rates as well. And while working in the big tech companies, they make sure about the ethics, safety, governance matter most. So have knowledge about the specifying human intent, reward hacking in the models, the interpretability along with the explainability of the large language model. Check about the data leakage along with the memorizations of the customer personal informations, and the it should have regulated with the GDPR or the data sovereignty pipelines. You have to make a human in the loop for the escalation paths as well. Okay, so now you understand how LLMs work, how they built and deployed. Let's move into how to make them more reliable and the knowledge grounded, so that their hallucinations, their factual inaccuracy can be very reduced here as well. So for that we use the RAG, that is a stage 2. So in this you will learn about what is RAG, why it matters, okay, and how it fixes the LLM limitations, and then deep dive into its architecture, engineering challenges, and the research work happened in the RAG as well. Start for RAG, so focus on the RAG concept, its motivation, from where it actually come and what it actually do to the large language model. Learn about combining the retrieval mechanism with generations to enhance the large language model responses, and why RAG matters and how actually it improves the factuality, the freshness of the responses, and the updation of the new data as well. Domain specific knowledge, the cost efficiency, and how you can use it for the enterprises or the big companies, Q&A chatbots or the customer support bots as well. Then learn about the RAG pipeline architectures, such as the how the RAG will use your all the documents, your all data, how it chunk it, and how it store in the vector DB, and how whenever a customer asks for a response, it first check that query into a vector DB, get its context, and then pass it into the LLM and generate the response as well. And that response can be pre-processed and so that it can be shown to the customer in a correct formatted way. Okay, so learn about the prompt augmentations, at how you can inject the customer retrieved context into the prompt, and how you can post process your large language model response to show to the customer with the proper resource citations as well. Okay, and then learn about the vector databases and indexing techniques, in which learn about the embedding generations by using the BERT embeddings, OpenAI embeddings, or the Gemini embeddings as well, and then learn about the indexing techniques such as the approximate nearest neighbor, the FAST, the HNSW, the annoy, along with the vector DB scaling techniques such as the sharding, replications, and then the latency optimization techniques as well. Also learn about how you can update the indices for the dynamic data in the batch or streaming services as well. Okay, so now you have know about the DBs. Now let's learn about the data retrieval and the ranking from those vector DBs as well in a more efficient way. So learn about the retriever methods, their design, their trade-offs of the sparse retrieval or the dense retrieval or the hybrid retrieval as well, along with the re-ranker, because the context or the documents that you get from the vector DB are in a very disoriented manner. You have to align them, you have to rank them in the top priority way, which is the most best suited context for your query. So you have to rank them. You can use the methods like the cross encoder ranker or any kind of machine learning models there as well. And there is also a concept called as multi-hop retrieval for reasoning across the multiple documents, or the chaining retrieval in the graph databases or the graph vector DBs like Neo4j as well. Also, you can learn about the retrieval matrices for evaluation like the recall at K, MRR, or the precision at K as well. Now you know how to get the data from the RAG. Now learn about its integration with the large language model. Now you have the data, you have the context, you have to put the data into the prompt so that it can easily go to the large language model with your query along with your context fetched from the vector DBs as well. So learn about how the retrieved context is injected into the prompt templates, prefixing, the chunking selection as well, and then learn about the context window limitations, because sometimes your context or your prompt or your query can be too big for a large language model actual context window. So learn about the sliding window technique, the relevance filtering or the summarization as well, and how to fix, along with learn about the new topics like retrieval on the fly or the static retrieval for the optimization of those retrievals, so that you don't need to read the DB again and again. So learn about the concept of store these retrievals as a cache or in a dynamic storage for the faster retrieval as well. Okay, and then learn about the RAG LLM project deployment and engineering its phase as well. So learn about the latency throughput along with its trade-off between the retrieval and the generation pipeline, because you have to retrieve the data from the vector DB and also pass that data to the LLM. So in that way, your latency got increased as well. So you have to make a trade-off between the latency and the throughput. Okay, and learn about how you can maintain the freshness of the new documents and also keep the stale documents apart, and to can reduce the data drift as well, along with the chunking strategies as well. You can also watch my full playlist on the Learn RAG from scratch, in which I explained about all the things that you can learn about the RAG or its chunking strategies as well. Okay, and then move to the evaluation part, because now you have the RAG, you have the LLM. Now you have to evaluate your RAG plus LLM pipeline. So a combined matrix of the retrieval accuracy, that how good the context is retrieved from the vector DB, and the generation quality from the large language models. You can use the matrices like latency, throughput, or the response time, along with the human evaluation matrices like the relevance, the factuality, the source attributions, or the customer satisfaction or the customer feedback as well. You can also check for the drift. Okay, because sometimes the your data is very old, so that you have to check for the drift or the retrieval hit rate, the generator accuracy over the time as well. Okay, after all this is done, there are some advanced topics that you should know and add to your list if you want to learn. That is called as multi-modal RAG, that helps in retrieving across the images, audio, video for the generation as well. Means now you have a like a PDF contain all the images, they contain the text data, they contain the tables as well. So you know how you can actually fetch all the data and store it into its separate vector DBs for the images, videos, or audios as well. And then when at need, you have to fetch the relevant context from those vector DBs and pass to the large language model as well. Learn about the memory augmented retrieval, like by using the long-term memory stores or the a small caching services as well. Learn about the tool augmented generation by using the retrieval, because whenever a tool is called, it can easily fetch the data from the vector DB and pass to the generation as well. If you have time, you can also research about the open problems of the retrieval latency for the real-time systems, along with the bias in the retrieval, the index fairness, or the retrieval robustness as well. These are the like major problems that are faced in the RAG-based generative AI systems as well. Okay, these topics helps you understand the actual engineering problems at scale better than ever. Okay, now you have seen how to ground the large language models via the retrieval or via the knowledge base or the vector DBs. Let's go further to the intelligence systems like Agentic AI. That systems can plan, act, use tools or APIs, and also remember as well. That's our third stage, okay, in which you learn about the what distinguishes an AI agent from a simple model, and then deep dive into its architectures, their designs, their training, their multi-agent tool use, or memories, or production and research areas as well. Okay, so first start with the what is an AI agent. The difference between the LLM or chatbot based on the autonomy, planning, tool use, memory, or the environment interactions. That why we need the AI agents if same thing can be done by the LLM with the APIs as well. Okay, and then learn about the agentic design patterns. Then for the most basic tasks like the multi-step reasoning, the tool chaining, along with the reflections, along with the self-corrected agents as well, the collaborative system with the multi-agent frameworks as well, and then move to the actual architectures of the AI agents, like the what is the motivation behind them. First we have is the perception, that is the input to the AI agent or the environment state, and then it's reasoning or the planning that include the chain of thought, okay, what it actually plans, and then it's execution by using the external APIs, databases, the code executors, the web search as well. Then it also uses its memory or the knowledge base as well for a short term case, okay, and the long term case as well, along with the dynamic memory as well. And the feedback or the learning loop is also there in the AI agent to keep them be on the corrective path as well. It has a self improvement or the logging of the agent decisions so that it learns from its every decisions and keep on improving as well. We have a multi agent setup that can coordinate between the multiple agents. There is the role, there is a task delegation or the agents hubs as well. After this, you can easily understand the tool use or the environment interaction with the AI agents as well. So learn about the tool invocation engines, such as how you can actually call a tool, actually call an API, or actually call a function by using the AI agents as well, along with the API integrations of the search, of the database query, of the sandboxing or the code executions as well. And then learn about how its observation and the action loops work, how it can sense, decide, act, observe, and learn, along with the error handling and the fallback strategies as well. Okay. After that, you can also add the memory into the AI agents as well, in which you can use the mem0 library as well. Okay, it can work as a short-term memory or the long-term memory as well. You have to learn about how to index memory for the faster retrieval as well. Or okay, you can also learn about the multi-step reasoning, means planning in the sequences or the branches or the backtracking or the reflection, as I already said in the previous case as well. Okay, then go towards the multi-agent systems, in which you learn about the architectures of a one master and multiple worker agents as well, and it can communicate between those agents. Already roles are assigned, their works are already assigned. A master agent can coordinate between all those agents as well, and also do the conflict resolutions. They can also learn, they can also adapt, they can also solve the errors as well. Okay, so all these things can be done by using a multi-agent system. So learn about that as well, that how you can build it in your own. If you want to learn about the Agentic AI, I already created a whole playlist with the 14 projects. You can watch that playlist and learn about the Agentic AI in detail with the projects as well. Okay, okay. So now move to the next part. So for the advanced topics in the Agentic AI, like training and the learning of the AI agents, you can use the reinforcement learning, that use the reward modeling or the policy gradients to actually make your model learn by using the exploration versus exploitation experiments, safe play training, along with the curriculum learning, so that it can learn with the each task with the increasing complexity as well. You can also use the fine-tuned large language model to make your AI agent for a domain specific task, to make it a very good for a particular domain or a particular task as well. Okay, and then alongside you can learn about the engineering and the production scale considerations about the deployment of these AI agents, such as the orchestration engines, their agent life cycles as well, the logging and the monitoring of the AI agent decisions, along with the guardrails, so that you can easily control what the agent can do or not do. You can also set the access control and the human in the loop for the safety as well. You can also check for the or learn about the latency and the responsiveness of these AI agents in the real time. And you can also have a governance team for these AI agents to make them audit, and you can have the explainability behind their each decision, because sometimes these AI agents can work by themselves because they take the every decision by themselves and can harm your own system as well. Okay, so now you have covered every component about the agentic AI. So now let's zoom out and see how all these pieces fit together into a full system design, a kind of architecture you need to find at a FANG or a large product-based companies. Now we at the stage 4, that is the FANG level integration, in which you learn about that how this stage bridges your theory or the hands-on learning you already learn with the components of the actual industry knowledge at the production scale as well. And how do you position yourself for a FANG or a very top level product-based companies by learning and positioning yourself towards a better AI engineer. So now learn about the end-to-end system design. So I recommend these 3 books. So you can also read these three books. These are the best books for learning the whole production level system design as well. You have to learn about the data ingestion with the streaming or the batch pipelines and all the things that comes under the system design of the machine learning or the generative AI. If you want to know more in detail, you can watch my this playlist in which I explained about the ML system design in detail for the FANG level as well, in which you will learn that how you can build your systems with the 3 end-to-end projects as well. Okay, you will learn about the scaling, you will learn about the infrastructure as well, you learn about how the model will serve at a scale by using the batching and asynchronous processing, model sharding on TPUs or GPUs as well, and how you can actually do the trade-offs between the latency and the throughput for the real time and the batch mode as well, and how you can scale your vector DB or the distributed computing you can use here to make your work at a parallel level as well. Okay, so you can choose these 3 books plus my this playlist as well for learning best about the ML system design as well. Okay, so you should learn about ML ops, the life cycle management of a whole project, if you are targeting for a senior role as well, in which you learn about the model versioning, registering, the rollback strategies as well. Okay, you learn about the experiment tracking, you learn about the CI/CD pipelines at scale or the database management, the feature store, along with the data privacy and the compliance issues as well. After that, you have to know about the security, privacy, and the governance issue. As I already told in my very first slides as well, you have to know about that how your data can be safe so that every user can use your large language model without any fear that your generative AI or ML systems can remember their personal details as well. Okay, so you should be well versed with the project KPIs, matrices, along with how companies judges success by using the business matrices as well, like engagement, revenue, or the cost saving. So for product-based companies, learn about that system design in a very detailed manner from these books or from my playlist as well. Okay, now, now, as you know, the AI field is moving really fast. So how you can keep up with that pace and how you make a habit to continuous learning and be updated about the latest AI research. So that's our stage 5, in which you can set up a reading habit, allocate the weekly time or the weekends to learn or to read about the new archive research papers, the newsletters as well, or the very good GitHub repositories that have all the latest research papers available and keep on updating every week. You can also subscribe for the research blog or the open source framework and join the communities as well, and you can interact with the peoples and network with them. You can attend the meetups, workshop, everything you can do to make yourself updated with the latest advancements in the AI field. And for your help, I created this GitHub repository for you on my profile that you can check, in which I uploaded all the resources that I have about the research papers, about the latest tech, about the tutorials, about the projects as well, along with the Medium blogs and the YouTube channel links as well. And in my next video, I will provide you the 9 high impact projects with system design workflows of LLMs, RAG, and Agentic AI that you can build before 2025 is over. So just be with me and build these 9 projects and also learn about these generative AI, LLM, Agentic AI from this roadmap. We'll meet in our next video. If you want to learn about the generative AI, RAG, Agentic AI, you can watch my videos on YouTube and also read my blogs on Medium. We'll meet up next video. Thank guys. Thank you so much.